Welcome into the video where we talk about spanning tree and VLANs. And if you've watched the videos previous to this, you've gone through the labs, you probably pretty much have a handle on how spanning tree handles VLANs. However, I wanted to make sure that I had a video in here that actually covered what the different types of spanning tree were, how they worked, how they came to be, because you may get some questions about this on the exam. So, when IEEE 802.1d regular spanning tree was introduced, VLANs just didn't exist. Therefore, spanning tree didn't have a provision for VLANs built into it, because they didn't exist. You can't build for something that you don't know is there. Now, the upshot of all this is that the switch, or the router, or whatever device is running spanning tree, runs one instance of spanning tree, and every VLAN on the switch uses that same instance of spanning tree. And the upshot of that is that it's not possible to use different links for different VLANs. You can't load balance your VLANs like we did in our lab, where we said switch A is the root for VLANs 1, 20, and 30, and switch B is the root of VLANs for 40 and 50. If you're playing by the rules and you're not using a Cisco switch, you have one instance of spanning tree, and that's all you get. In response to that, Cisco implemented a proprietary extension to the spanning tree protocol, and if you've gone through the labs, you probably have figured out what it's called. It's called PVST, or Per VLAN Spanning Tree. Some Cisco documentation refers to it as PVST Plus, but it's the same thing that we've been playing with in the lab. And the upshot of PVST is that it allows the engineer to change parameters in a per VLAN configuration, and it forces traffic to go over specific links by changing which bridge is the root bridge for the VLAN. You can also go onto your trunk ports like we did when we set up trunking and say this particular trunk port can only carry VLAN 1, this other trunk port carries VLAN 5. And that is a Cisco proprietary extension to spanning tree, and as you can see, it worked pretty well. So then Rapid Spanning Tree came along. The IEEE ratified the 802.1w standard for Rapid Spanning Tree, and surprise, surprise, there's still no built-in method to manipulate Rapid Spanning Tree on a per VLAN basis. In response to this, Cisco implemented yet another proprietary extension to Rapid Spanning Tree. You probably know what the name is. It is called Rapid Per VLAN Spanning Tree, or Per VLAN Rapid Spanning Tree. The documentation uses both of those names seemingly interchangeably. Why they can't just pick one and stick with it, I'll never know, but you know how it is. And essentially, it acts exactly like PVST Plus, but it uses Rapid Spanning Tree instead of the regular spanning tree. And again, we've talked about the differences between the rapid and the regular spanning tree. So the IEEE finally got their act together, and they introduced 802.1s to solve the issue once and for all. They implemented what is called multiple spanning trees, or MST. This is also referred to as MIST, which is multiple instances of spanning tree. But most of the time you'll see it referred to as MST, so that's why I didn't put the second acronym on there. Now, unlike Per VLAN Spanning Tree and Rapid Per VLAN Spanning Tree, this is an open standard. It is implemented in the 802.1d-2005 standard when it was all rolled together, which means any switch out there can use MST to control what VLANs use what spanning tree instances. And essentially the way MST works is it allows the engineer to specify spanning tree instances. And you say that switch 1 is the root for instance 1 and switch 2 is the root for instance 2. And you assign VLANs to those instances. Now, the difference between the two is that MST runs 1 or 2 or 3, however many configured instances of MST you have running, whereas Per VLAN Spanning Tree runs a separate instance of the spanning tree protocol for every VLAN on your switch. If you have 125 VLANs configured on your switch, you're running 125 instances of the spanning tree protocol. And as you can see, some lower-end switches might start to get bogged down under that load. That is the advantage of MST. You can configure exactly how many instances are running, and you won't use too many resources on your switch. That being said, even though MST is, in my opinion, a somewhat superior protocol, it requires a lot more configuration on the switch, and I've only seen it used in one instance, and that was when Cisco came into a network that I was helping to administer, and they set it up for us. Now, I'm not going to go into much more detail about MST because it's not covered in the ICND2 or the CCNA exam prep or on the exams, but you do have to know it exists just so you don't get too confused whenever you run that spanning tree mode command and you say, hey, what's this MST? And you turn it on and your network comes crashing down around you. And that's it. That concludes our discussion of spanning tree and VLANs.